This battery box gets its first sea trial next weekend, and before I take it out on the water and rely on it for anything, I want to get a few operating parameters first. What I have here is a simple digital multimeter and a couple of electronic loads. These are 300 watts apiece. I have two of them in parallel to simulate the approximate 600 maximum watt load of the trolling motor, and a thermal imager because I want to see if anything in here gets hot. So I'm going to fire this thing up, fire up these loads, load it up, and check some voltages because I want to look at the voltage drops within the box and the cable to see how much power I'm losing in both, and compare my current readings from the electronic loads to the monitor to see how accurate that is. So, turn it on, and we should see here at the connector we got 13.4, underload, load on, load on. So these are pulling 24 amps apiece, and pretty soon the fans will kick on because they're going to get hot, and you might not be able to hear me. So we've got 12.15 volts at the load. We've got 12.59 at the connector. We've got, yeah, there they go. Come on. .88 at the battery. And you won't be able to see this, but I'll put it in the video when I edit it so you can see what I see. So far we're holding at about 32 centigrade, which should be just a slight rise above ambient. Yeah, it's about 10 degrees above ambient. Let's compare the current reading here. We've got 50.1 amps, and that's about right. We're up to 25.1 and 25. So yeah, that's nearly right on. What I wish I could see is the temperature of the contacts inside this connector, because those are the parts that'll get really hot, if anything gets hot. So far, no sign of trouble. Still pulling 50.1 amps. That's measuring 50.2 now. Yeah, I guess it's closer to 50.2. 25.2-ish here and 25 even there. We're up to 41 at the connector. So what makes me nervous about these connectors is I think that their current rating is a little overstated, and they get away with that by stating a higher than industry standard temperature rise at the rated current. So that's why I want to check this. The typical temperature rise at the rated current is 20 to 25 C over ambient. But these guys spec something like 40 C over ambient. And what that means is that if the maximum operating temperature range is 85 C, then the maximum ambient temperature range at which you could operate at full load is 45. That's why that's important. On a hot day, what's the temperature inside the box? So we're up to 43, or probably 23 ambient, so 21 rise over ambient so far, 45. This is probably going to creep up for a long time, but I don't know how far it'll go. And these are holding at 300 watts apiece, so as the battery voltage slowly falls off, the current is going to increase. And that is going to impact this as well. Getting a little bit of temperature rise in the cable, mostly toward this end, which is probably from the connections inside. We're at about 10 over ambient on the cable. Yeah, and holding pretty steady at 45. I'm going to, oops, drop my phone and mess things up. I'm going to capture a phone image from this same perspective so that you have a visual reference for the IR image. Because without that, it's a little bit abstract. Yeah, we're holding pretty steady. About a 22 rise over ambient at probably what, 50.3, 50.4 amps, and so we've burned 15 amp hours. It should go for about an hour and a half at this rate to completely discharge the battery. The temperatures have stabilized at this point, so 22 over, 23 over ambient. That'll do, pig. That'll do. Well, that's a pretty good result. At full load, the voltage drop in the motor wiring inside the box is 290 millivolts, and the voltage drop in the cable is 450 millivolts, and that's over about, well, probably 2 meters of cable, and the final application won't have that much cable, so I'd expect that number to drop a little bit. And now I'll move on to testing the low current outputs. What I've done with that is I've just put all three in parallel, and I'll set this bottom load to 15 amps, so assuming that they share the current more or less equally, it'll be 5 amps apiece, which is full load for those. Contacts are rated at 5 amps. And I'll pull another 25 amps, 300 watts on the motor connection. And I'll measure the voltage drops again, though I don't have the ability to probe the connections in here because I was so diligent about heat shrinking them. So I'll measure at the battery terminals, and there's a voltage display here on the electronic load. Power on, 13.33 volts at no load. Fire it up. Low current loads. And all three of these loads are fused at 10 amps. So we shouldn't have any trouble. Pulling 15 amps. Voltage has dropped to 12.5. So as we're pulling 39 amps even. We got 15 and 24. So yeah. We're there. 500 watts total right now. And 12.89 at the battery terminals under load. We've got currently 12.43 at the load, so that's a total of 46 millivolts drop. Oh, sorry, not 46, 460 millivolts. So to put that in perspective, at 39 amps, well, it's 460 millivolts. It's approximately half a volt, so 19 and a half watts of power is lost in all the wiring. Not too bad, about what I expected. What remains is to see if these connections get hot. Well, the tiny little bit that I can see of the connector inside says, reads about 25 centigrade. And nothing in there is even warm yet. I don't think it will. I don't think it'll get warm. This thing says I could run 2 more hours at this load to 100% discharge. If that's believable, that's pretty sweet. These things are putting out some heat. Voltage is holding steady now at about 12.34. We're into the really flat part of the discharge curve. And this, the cable is holding at 30. Can't get to the contacts inside or out, but they're clearly not on fire and not even warm as far as I can tell. So I would call this a successful electrical test. Again, not a full load system level test, but the best that I can do. I'll let this cook a little while, see if I can get it down to around 50%. And then I'll put the charger on it. And I won't ask you to sit through that. That's a very slow process. There's another test I'd like to do. I didn't design this box for an IPX7 rating, but it sure would be cool if it could survive a dunk. I mean, it's supposed to be for marine applications, right? And it's a little bit risky because I'm going to be using it for the first time in a few days. If I screw something up, it'd be kind of SOL. I'm gonna do it. And I see only one potential problem. And it is from the component that I most suspected would have a problem. That is the kill switch. I've been seeing bubbles come out of it. But they seem to have stopped, so maybe it'll be okay. I'm going to let this chill here for a while, maybe half an hour or so, and then open it up and we'll find out together whether or not the thing is really watertight. Alright, it's been about 35-40 minutes. Let's see what we got. I am going to carefully dry this thing off on the outside so that water running in post-test is not mistaken for a leak. Okay, moment of truth. So, what I see. I see a little bit of what could be seepage around the seal here. It could have gone in at the moment that I opened it. I'll take you with me so that you can see this, but please forgive my poor camera operating skill. A little bit of seepage around the seal, possibly. That much is a little bit difficult to tell for sure. Is that a drop right there? Yeah, possibly a drop right there. Could also have been from when I opened it. But I'm not seeing any water ingress, for example, around these connectors, around the power switch, or around the kill switch as I expected. So that's a good sign. Nothing. Oh, I pulled in water with my finger. Let me dry my finger. Try that again. Feel around there. Oh, there is. It's a little bit wet around that connector. Yeah, okay. Kind of looks like maybe a little bit might have seeped in here. I might need to tighten up these screws a little bit. But you know, it's not too bad. Okay, yeah, there's a little bit of seepage down there from this connector, it looks like. Yeah. Okay. Can't call it IP7X, or IPX7, I guess. Oh well. Pretty damn good still. I think that's enough torture testing for now. It passes all the electrical testing that I can subject it to with flying colors. It does as well as I can expect in a submersion test. I'm pretty pleased with it, and I'm pleased in general with where the project is going. The next part of the project, I'm super excited to get going on it. That will be integrating the battery box into the Kayak electrical system as a whole, fabricating a transom motor mount, modifying the motor. I want to bring out a remote throttle and remote steering, and there will be through hull wiring. So all these connectors will cable out to the hull, and the rest of the wiring will run through the hull so that it's clean, and we'll cable out to some USB charging jacks and a fish finder. I'll cable out to the battery monitor, and I'll create a box and mounting for that. Cable out to another power jack at the stern for the trolling motor. Another big portion of the project, and yeah, it's going to be great. Thanks for watching.